Honestly, if I just project, can everyone hear me? Sweet, that is so low. All right, hi everyone. Thanks for making the time to be here today. The title of my talk today is From Research to Impact. And I just wanted to take this time to share some lessons on lessons I've learned in being an effective data scientist in the public policy space. So I thought I'd kick us off with an introduction first, and a little bit about me. My name is Thiyaghessan. You can call me Thia for short. I am a data scientist at the Urban Institute, and the Urban Institute is a public policy think tank. We were founded in 1968 to assess the effectiveness of President Lyndon Baines Johnson's Great Society reforms. And since then, we have evolved considerably and expanded considerably to do all sorts of policy analysis and evaluation for the federal government, corporate funders, philanthropies, and private foundations. We have over 600 employees, and we are currently headquartered in DC with a very generous remote work policy, which is how I could be here today. Specifically, the team I work at the Urban Institute is the National Center for Charitable Statistics, also known as NCCS. So what is NCCS? It is a sort of repository or clearinghouse for all research and data on nonprofits in the United States. So any nonprofit from a soup kitchen all the way out in Oregon to a giant foundation like the Bill and Melinda Gates Foundation, we are responsible for aggregating all of the data that these organizations of the federal government. And in my spare time, I also moonlight as a data journalist in my home country of Singapore. Happy to chat more about that outside of this talk, if you like. But otherwise, I'll get right into talking about the data that I mostly work with. So I said that nonprofits submit data to the federal government. What do they submit? They are primarily regulated by tax law, which means they are required to file taxes with the IRS every year. So every year, if a organization wants to acquire nonprofit status, they first register for tax exempt status with the IRS, and all of this gets put into a very, very long business file that contains demographic and legal information about every nonprofit. And then each year, every nonprofit is mandated to submit yearly financial disclosure via one of three forms: the Form 990, Form 990EZ, or the Form 990PF. My job over at NCCS is to sort of clean and process these records. And we're talking about terabytes of data, and we're talking data that stretches from 1989 to 2024. And my job is to make this data publicly accessible and available for social science researchers, nonprofit analysts, policymakers, grad students, and various other individuals who are looking to understand the size and scope of the nonprofit sector in the United States. And we're the only repository that goes as far back as 1989 because we were the only team that started manually scanning IRS tax records all the way back in 1989 from folders of DVDs that the IRS would send over to the Urban Institute. Thankfully, things have evolved considerably and we no longer need to do that. But because we've done that work, we have very, very extensive panel data that stretches all the way back to the 1990s. So what does this data look like? The IRS tax forms are in sort of raw XML and PDF formats. There are over 20 parts with 10 schedules and various attachments. They are dumped by the IRS in raw XML or PDF at irregular cadences, sometimes monthly, sometimes quarterly, sometimes yearly, depending on how much funding they get from the federal government. And they also release aggregated statistical tables in Excel format and also send over metadata on nonprofits in TXT files or CSV files. Now, what does a Form 990 look like? It looks something like this. And if you've ever run a nonprofit or want to know what running a nonprofit is like, it requires you to fill it up once a year for auditing purposes. And this is only part one of the form. The full form itself has over 20 parts with over 10 schedules that every nonprofit must fill. And it contains a lot of unstructured data. So it's like in raw XML format, this is what it looked like. And each form can range from, I don't know, a couple of hundred kilobytes to about 2 MB of data. Extremely unstructured, very messy, and also the schemas are not consistent. The IRS releases schemas that are sometimes outdated. So they might release new waves of tax data that don't map accurately to that schema. And that would require you to do a little bit of detective work to figure out what has changed in schemas. And also, the schemas they release often could have incorrect data types being annotated. So you're really trying to churn through terabytes of extremely messy, difficult to structure data sets. Now that I've set the scene and I've told you what I'm working with, I'm going to proceed to talk to projects we've worked on using this data, what being a data scientist at Urban is like. And I also want to then move on to talk about how we sort of understand what our users want from this data so that we can better serve their needs, how we optimize our technical stack to better meet these needs, and also some final thoughts on project management and internal collaboration at a public policy think tank. Now, with all of the tax records, like what are some of the public-facing projects that we engaged? One of the biggest projects that we engaged in this year was a nonprofit financial risk data tool that basically visualizes nonprofits' dependence on government funding in the US. It has been featured across over 50 media publications, from the Boston Globe and the New York Times to the Associated Press. And it's also been consulted heavily by Congress, universities in response to the federal funding cuts. And now I can do a short demo of what this tool looks like. This tool is essentially an interactive data visualization that allows the user to select a particular state, and it then populates a table highlighting every nonprofit in that state and how dependent it is on government funding. So in response to the recent federal funding cuts, this tool has been really helpful for congressional representatives to understand how dependent their local nonprofits are on federal funding. And it also allows policymakers to understand just how at-risk nonprofits are. And this data can be drilled down into the county level, the congressional district level, and we also are able to categorize nonprofits into very granular subsectors. And so this has been really helpful for a lot of policymakers who have been trying to identify evidence that can help highlight the impact of these funding cuts. And I am really hopeful that this will lead to some constructive change in the policy landscape down the road. Another thing we do is we create really massive general use data dashboards that essentially allow users to, in real time, aggregate and visualize all of the data submitted by nonprofits to the IRS to be able to plot sort of trend lines, visualizing and like select financial metrics, and be able to disaggregate them by, as I demonstrated earlier, geography, size, subsector. And we also create data dashboards that allow users to assemble really custom panel data sets for them to basically retrieve curated data marts from our massive data lake. We average over 8,000 users, and I will later on explain how we set our technical stack up to service this, this level of requests at a very low cost. Thing we have is our website, and that is really where all of the publicly accessible, clean, and processed raw data sits for researchers. We have demographic data on nonprofits, financial metrics, reproducible code, and of course, lots of detailed technical documentation for all of the researchers who use our research the social sector in the United States. So I've shown you what we do, from niche high impact tools to much more big picture publicly available data sets. What does data science at the Urban Institute? As a data scientist at the Urban Institute, you're very rarely working by yourself. You're also required to wear masks because you are often the only data scientist on your team or the only programmer on your team. That means you are sometimes a software engineer, a data analyst, sometimes a data engineer, sometimes a front-end web developer, and sometimes a statistical modeler. In short, you never become an expert in any one of these things, but you sort of become this jack of all trades, able to very easily pull something out of the hat to get like a data tool going. Now, who do you work with over at the Urban Institute? Work with primarily 5 different types of collaborators, all of which bring different types of expertise and have a specific role to play in the organization. First type of person you work with is researcher. These are tenured professors, academics who have spent their entire lives researching the social sector in the United States. They know all of the latest methodologies. They have a lot of domain expertise. They can tell you why in 2002, a change in IRS regulation meant that the revenue variable is not the same as the revenue in 2003, right? They're really good at getting into the weeds and identifying all of the little caveats that you need to understand as a business. You also work at policy analysts who are able to take all of that research and just hone in on the findings that are going to be relevant to policymakers, who often just pick 1 or 2 numbers as a final deliverable and are not really interested in the overall research process. You also have to work with operations staff who are communicating with funders, responsible for managing your project timelines, and who you're going to be working with when you scope technical projects to ensure that they get completed on time and on budget. You'll also be working with the communications team. Now, as a data scientist or programmer, you might be really excited to try some front-end development tool. But the truth is, if you're working in an organization, if that tool here to the organization's branding standards, then you will never be able to deploy that tool to production. And so the communications team's job is to help you understand what aspects of your front-end development process align with the organization's like branding requirements. And the final set of collaborators you work with are technical experts. So these are statisticians, software engineers, simulation modelers, and they are able to review specific technical aspects of your work and give you a sort of really niche consultation in research methods. So your job as a data scientist is to bring all of these people together and sort of translate research into impact. And that happens through a very, very long 8-stage process that starts with ideation, goes to technical scoping, leads to prototyping, for development, iteration, finally a review for quality assurance, and leading to your final deliverable. I would like to think of this as a linear process, but the truth is this is not a linear process. You are often going 2 steps forward and 1 step back, because maybe a researcher might have a new idea, they want to integrate into the final product, maybe funding requirements may change, or maybe your communications team like how your dashboard looks. So you might have to go back to the wireframing drawing board to edit the final deliverable. So as a data scientist, you're kind of sitting, you're accompanying throughout the entire life cycle. You're trying to get inputs from all of these different collaborators while pulling your software development, data engineering, front-end development hat in them so that you can release a product on time and on budget. So as I mentioned earlier, when starting this job, there were a bunch of challenges I was encountering, because to bridge research and practical applications, I had to first understand our user base. So a lot of our high impact tools are only possible because we understood what exactly our users wanted from them. And when we first started at NCCS, we did not have a clear picture on who these users were. We also did not know how to optimize our technical stack to achieve these goals and to create these tools, both on time and with as little resources spent as possible. To figure out how to collaborate effectively, especially with a think tank that was just starting to integrate data science into its public policy applications. And as you can tell, currently operating in an extremely fast-paced policy environment. Executive orders are being issued weekly, and you often have very little time to react. A lot of the times now, your deliverables need to be released within a 4 to 8 week development cycle. as opposed to the 3 to 6 month development cycle that has traditionally been enjoyed by data science in the public policy space. So you really want to understand your users, optimize your stack, collaborate really effectively so you can get projects out the door as quickly as possible before the news cycle shifts to the next big thing that the administration is talking about. So how do we understand what our users wanted over at NCCS? The first thing we do to engage our users is we hold office hours where we invite members of the public, researchers, etc., to come and sit with us in a Zoom room and talk to us about their use cases and to talk to us about our data sets and how they use their data, how they use our sets in their day-to-day research. We also offer free custom data request analysis as long as they involve less than 10 hours of work. And the reason we offer this free service is so that we can then chat with us a little bit after and tell us about what they like to see from our technical products. So what would they like to see from our packages? What would they like to see from dashboards? We also have logging of our download metrics, and we have mandatory user information being submitted in our API calls, like your role in an organization and descriptions that users have for specific downloads. And we log those to determine which of our data sets are the most popular and which of our microservices are the most popular. And we also conduct extensive focus group discussions where we bring together diverse groups of users, we demo new tools, new features, new UI changes, and we try to solicit as many different opinions as we can about which direction they take our tools in. Through this process, we have kind of understood that in the world of nonprofit data, there are a few different types of users. There are academic researchers and there are general researchers. Academic researchers are professors and researchers who work at academic institutions. General researchers are sort of policy researchers, nonprofit analysts who are just looking for very aggregated summary statistics. We also have two other different types of users, which are programmers and non-programmers. So starting from the left, academic researchers really want to be able to do everything from scratch by themselves. They want to be able to build their own custom ETL pipelines from raw data into research-ready data sets. They want custom R packages, and they want to be able to reproduce a lot of your methodological findings at scale. Meanwhile, generalists who might also be programmers don't require that level of detail or fidelity. They simply want panel data sets they can easily are. They want some guidance on how to join data sets and how to map records to one another. And they also want very simple data dictionary in what is in each column. Your non-programmers who are academic researchers, they really want to get into the weeds of your methodology. They want full descriptions of all the caveats of the data. They want detailed research handbooks. They want peer-reviewed citations. And they're also very interested in sort of taxonomies you use to classify your data, taxonomies you use to classify your nonprofit records. And the last kind of researchers who are not programmers, they are just really interested in summary statistics, visualizations, and very small data marts that they can load on Excel on their computer. When we plot this out, we realize most of our users are actually not programmers. And in fact, most of them are general category. I think as a data scientist, when you start out, you get very excited to develop R packages and APIs, only to realize that, only for me to realize that most of the users don't really use any of that. And what they want instead are very curated data marts that they can load into Excel. So when we think about products in CCS, we've realized that ultimately small files, no code or low code dashboards and data tools, and very short form content is what we want. But to be able to get there, we also need to have the big panel data sets, public APIs, and R packages that can be used to engineer and analyze this data that is also going to meet the needs of our more technical users. So ultimately, I realized that for us at NCCS to maximize our policy impact, we have to focus mostly on our general researchers who are primarily non-programmers. no-code or low-code applications, interactive and customizable visuals, curated data marts, which are really small Excel files under 10 to 20 megabytes. And at the same time, we want to be able to prioritize these things without neglecting our sort of more technical, more power users. So ultimately, as a data science team, we have ownership over our cloud data engineering stack, and we use our data lake and panel data sets and detailed documentation that can be used by our academic researchers. We then use those to develop our packages and APIs can be used by our programmers. And then ultimately, all of those feed into the curated data sets, dashboards, and short-form content majority of our users who are general researchers and non-programmers want to use. And this leads us from that 10 terabytes of raw unstructured data into partitioned Parquet files, and ultimately very, very small CSV data marts that are highly curated and processed, and no-code dashboard operations. Now, how do we optimize our technical stack to deliver this? I think in the world of data science, you are often spoiled with too much choice. And so I found it really helpful at NCCS to start development from understanding principles of constraints. Our constraint is that we have one data scientist, and that is me. So I really need tools that are very easily maintainable. We are funded on a grant model, which means funders are very reluctant to commit to long-term maintenance of technical assets. So I really want to keep infrastructure costs as low as humanly possible. And also, we have organizational requirements, like I mentioned, in that everything we do has to adhere to Urban's branding, Urban's data security policies, and Urban's quality assurance policies. I know that the IRS releases tax records in very messy XML, XLSX, and PDF formats. I know there is structured tabular data and unstructured XML data. And this data is very low velocity. It's not real time like credit card data, weekly, monthly, yearly, quarterly cadences. And the majority of our users' queries based on user research are going to be analytical queries. They're not looking to join records. They're really looking to compute summary statistics and aggregated statistics. What I want to optimize for is columnar aggregations of the structured data. And there's going to be less of an emphasis on base joins for our non-programmer user group. Now, choosing your technical stack is very, very challenging because there are 1,001 companies offering you 1,001 solution. But I have found it really helpful to just segment things into this really useful 2x2, you know, what is cheap, what is expensive, what is maintainable, and what is complex. And if you just focus on what is cheap and what is maintainable, you can almost everything else on this product. So we focus on lots of open source, very flexible, highly maintainable tools that can easily be prototyped and iterated upon to meet our 4 to 8 week development cycles. So what does our overall system look like? Start with our raw data, which are these XML and Excel files. We have our first ETL layer, which uses R packages, DuckDB, which is optimized for columnar aggregations, and AWS Lambda functions. And we dump all of these into our data lake. And our data lake consists of more files with really detailed schemas that have strict handling of data types. And the reason we have R packages in our layer 1 is that these packages can be used for us by us internally for data engineering, and we can also open source these packages to serve our technical users and the customizability into creating their own data pipelines to transform the raw XML data into Parquet data sets. Now, from our data lake, we then have a second layer, which uses DuckDB databases, serverless APIs with Amazon Athena and API Gateway. And that allows us to create curated data marts, our Shiny dashboards that serve these data marts to users, and Porto fact sheets that can be used to create the sort of templates that go into some of the data tools that we've developed. And ultimately, to ensure that these can be deployed in production and be on our website automatically, we also use GitHub Actions and GitHub Pages to serve that exists on these static web pages. So what is the overall output of this entire system? The overall outcome is that our infrastructure costs are under $100 a month, which is something I am personally extremely proud of. And I have a big smile on our face whenever I look at our bill every month. I prioritize using a serverless architecture because, like I said, I work with general researchers, and for them, real-time serving of data is not very important. So because they're okay to wait for 10 seconds, I do serverless and I just use my shiny front end to take their request, trigger the backend Python process, and then send them an email with their curated data marks. Very easy. Our events trigger Python backend processes, no extra layers of communication needed, and also much easier to debug than a. And also one of the reasons why I keep my front end in R is that a lot of the researchers I work with only know R. I would love to work in Python for data engineering. Making your code inaccessible for the rest of your team is not a good strategy for collaboration. And honestly, it will make researchers feel left out of the development process. So often think about who knows what in your organization before rushing in to choose the most optimal solution. And like I mentioned earlier, we use GitHub pages for static web content. And one way we avoid paying for expensive enterprise database providers is that we go and take a look at every column and write very detailed schemas for each and every one of them. It's a lot of grunt work, but honestly, it's so much money down the road. In the interest of time, I will skip this part, but I just want to say that a lot of the tools that we use are extremely flexible and easy. And Porto allow for very easy wireframing with the rest of your team. You can very quickly iterate and show your team what that looks like. Also, they allow for very easy configuration of custom CSS. And this really ties into the organizational branding component. GitHub Actions allow for free deployment to production, and they're very easy to use. And also, as mentioned earlier, serverless architectures, which I'm a huge fan of, can really be proliferated on very quickly. Now we have our technical stack and we understand our users, but we also need to loop in everyone else that we're working to deliver some of our data products. One of the strategies I found very helpful when working with members of my team who themselves are not programmers is using pseudocode. Now, you probably have learned pseudocode in your computer science classes. I hope you have. What I'm talking about pseudocode, I'm talking about an even simpler form of pseudocode, where you literally write in plain English what you're doing with the data for your team to see. And this is really important because a lot of the times the policy analysts that you're working with are not going to be programmers, and you want their inputs into how you're wrangling the data because they will know if you're making a mistake during the analytic process. And this allows not only the policy manager to have the faith and trust that what you're doing with code is what they think you're doing. And this is really important, especially in today's policy environment where think tanks are very sensitive to the political risk of any findings they release. So as many of your internal collaborators as possible need to be clued in into what you're actually doing your data analysis. Another thing that we do to foster effective collaboration is that we also create a lot of intermediate layers for quality assurance. So in developing a dashboard, it is very time consuming to have a list of changes, read through the dashboard, and then demo it to your team. Instead, using a lot of UI editors for wireframing, using Google Sheets for intermediate data outputs, and using Porto documents to render intermediate HTML outputs is a really helpful way to get the rest of your teams to review sort of the work that you're doing. And I know a lot of data scientists love to dump everything into a dashboard, but not. I think Google Sheets works just enough because everyone knows how to use Excel, and you can automatically feed all of your outputs into a Google Sheets for multiple collaborators to inspect outputs. And ultimately, I think the final thing that we use to foster effective internal collaboration is effective project management. So we have a nice little free Airtable plugin that we use to keep our researchers on task. And I just want to say that when you're working in a think tank, you're often going to be working with who are very big picture thinkers. They are juggling multiple projects. They don't really pay that much attention to deadlines. But ultimately, in the policy environment that's very fast, you want to be able to keep them on task and give you the inputs you need. And hence, I am a huge proponent of using some sort of project management software that works for you to help you keep track of what your researchers are working on so they can sort of push and communicate the deadlines to them. So I think another challenge that I do encounter in the think tank space is that when I work with a lot of stakeholders, they have a lot of ideas and they want to add them to your dashboard or your tools. Project roadmaps are very helpful then, because whenever someone suggests a new feature that you know you don't have the time to develop, just tell them you're going to put it in version 2, and that way everyone is happy. We are almost at time, and I wanted to end with some final thoughts on working as a data scientist in the public policy sector. The first thing is that I think it's really important that you understand what a data scientist. That is, you are really a functional member of the team, and everything you do contributes to project expenses. So every instance you spin up decreases the amount of grant funding that's available to another member of your team to do their work. Every tool you develop also takes away resources that could go to someone else. So you want to be really judicious with how you spend your money. And I think this ties back into the imperative I feel to keep costs as low as possible, right? And once again, I really want to reiterate, grant funding really makes long-term maintenance very, very tricky. So assuming you're going to have runways 6 months out and 8 months out, especially in this funding environment, is extremely risky. So as much as open source tools, free tiers, getting as scrappy with it as humanly possible is really going to save you a lot of pain in the long run. As a data scientist working with non-technical team members, your role is to really reduce complexity as much as possible. I know fresh out, I was really excited to add complexity by developing really complicated pipelines and really fancy APIs. But based on the user research I did, people don't want that. They want a number, they want a CSV file that they can open on their Excel terminal, meet them where they're at. Don't engineer it. And also, when you communicate to your team members, speak to them in plain English. Avoid using overly technical jargon. I know we have our own terminologies and definitions for things, but there is no easier way to lose your collaborators by starting to talk about, I don't know, schemas or typesetting or something like that. Don't talk about that. Use plain English as much as possible and walk them through the process. Think about it as you and them versus the problem, as opposed to you versus each other when you're trying to get them to understand something. And also the final thing is, I really think coding is secondary in this job. I think a lot of it planning first, planning early, coming up with a technical scope that allows you to complete a project feasibly on a budget. And only when you have a solid plan where everyone's clued in on the analysis, understands the analytical form, and can repeat back to you what you are doing on the technical end, is when you know your project is ready for you to move on to the next phase, which is software development. A lot of the devil is in the details, especially in policy work, and detail like planning and scoping is one of the only few things that loops everyone else in that maximizes your chances for success. And with that, I think I'm at time, and just want to say listening to my talk, and I'm happy to take any and all questions.